Hello. Again, we have another math challenge here. Let's look at it together. How do we solve for the value of x here? Here we have the question is x to the power of 625 equal to 5 to the power of x. What is the value of x here that will satisfy this equation? And if you look at this exponential equation, you discover that x has about 625 values that will satisfy this. But are we going to solve for all roots to this challenge? No. We're going to solve for just one of the roots here. Okay, but ideally, we have to solve for 625 roots. But for the sake of this class, we're going to limit ourselves to just one. So how do we get that one root to this challenge that will satisfy this equation? That is the aim of this class. So let's go into this challenge. Okay, so let's take our solution first. Solution. Now look at this expression we have here. We want to take the x root of both sides. In other words, we want to raise both sides of this expression to 1 all over x, the power of it. Okay, so this is going to give us our x to the power of 6 to 5 all raised to the power of 1 all over x. This is equal to 5 to the power of x all raised to the power of 1 all over x. This is a power, this is a power. And according to the rule, a very common rule, we say that if you have k to the power of your m n, this is equal to your k to the power of m in bracket n equal to your k to the power of n bracket x. Now, if you look at this, let's rule it out here because it's just a theory you want to make use of. If you look up here, look at what we have here. It's similar to this. And here we are now saying that we can multiply these two out here. So we want to use this to multiply this. So if we do that, what happens? This and this will leave the system. And so we're going to have here, and we can equally use this to times x. Or let's bring this out and take this in. So this is going to give us our x to the power of 1 all over x, or in bracket, r raised to 6 to 5. This is equal to our 5 here. Easy. I believe we're clear here, right? Now, from what we have in here now, again, we want to take this 625 root of this expression we have here now. Applying this same law again. And so, yeah, we're going to have this to be our x to the power of 1 all over x, yeah, all raised to our 6 to 5, yeah, then I want to raise it here now to our 1 all over 6 to 5. This is equal to our 5 all raised to our 1 all over 6 to 5. Yeah. Easy, right? Good. Now, if we apply this rule again, what happened? Then this will go with this. So we now end up having our x to the power of 1 all over x. This is equal to, look at this here now. So we're going to have our 5 to the power of our, okay, let's just put this in power here, okay, bracket, our 1 all over 6 to 5. Let's continue here. What this gives us. Now, look at this. Here we're having x to the power of 1 all over this expression. So we know that this could be written as 5 to the power of 4. But if we do some manipulation, it will not work out. So all we need to do is to raise the whole of this expression to power 1. In other words, we want to take this to the power of 1. This has not changed anything. And so I want to bring out a fraction that will cancel out. It will still give us 1 here. So we want to rewrite the left-hand side. So we're going to have our x to the power of 1 all over x is equal to, we're going to have our 5 here, bracket, our 1 all over 6 to 5 into our square bracket, all raised to bring in 5 all over 5 here. So we have 5 all over 5 in here. Okay, so with what we have in here now, this is multiply this. And if we apply this law again, I want to move this in, or one of the fractions only. All right. So let's rewrite this. This is going to give us here our x is here 1 all over x is equals to, I want to separate this from this. So this is going to give us 5 to the power of 1 all over 6 to 5. Okay. To avoid writing of many brackets, so this is going to give us 5 here times 1 all over 5. And so I want to move this one in and use this to multiply this. So if I move this in, this is going to give us x to the power of 1 all over x is equals to 5 to the power of 5 in bracket all raised to 1 all over 6 to 5 times 1 all over 5. Now the question is, what is 5 to the power of 5? We know that 5 times 5 will give us 25. Times another 5 will give us 125. Times another 5 will give us 625. And times another 5 will give us 3125. And so this expression we have here is going to give us 1 over x here equals to 3 here, 1, 2, 5, all raised to, we have this times this, so this is going to give us 1 all over 3, 1, 2, 5. What we try to fight for is that to have expression of this kind on this side also. So if you look at this, we are having x raised to 1 all over itself. So here we are having this number raised to 1 all over itself. So what does that imply? By comparison, we can say that our x is equals to 3, 1, 2, 5. Or 1 all over x is equals to 1 all over 3, 1, 2, 5. Of which if we solve for the value of x from the exponent, also we're going to have 3, 1, 2, 5. So we can therefore conclude that therefore our x is equal to 3, 1, 2, 5. All right. So this brings us to the end of this class. And mind you, I said earlier on that we have 625 solutions or routes to this challenge. In fact, we have infinite solutions to this. But here, we just have to narrow this class to just one of them, of which 3,125 is one of the 625 routes we are supposed to solve for. Yeah. Thanks for being there. Thanks for watching. Till we meet you in our next class, do not forget that Jakes does love you. Bye for now.